Okay, so I think we can start. So last class, as I mentioned, like we have discussed about SLAM, and we have been like going through different SLAM algorithm that is available in the form of ROS packages. So we have started with ROS G mapping. I think you have you may be knowing this package is very popular, and we have gone through some example and we tested with the turtlebot 3 examples. Okay, we also discussed the input output, what are the topics that is subscribing, what are the topics is publishing, and the demo. So we can start from the G mapping, like after the demo, like we can start with the demo of the G mapping. We already discussed this stuff, and after that I'm planning to switch to the cartographer. I'm not sure I can able to build it, but seems like yeah, it seems like it is not building. Maybe after the demo we can try to build the cartographer. So in the meantime I can share the link that we are planning to discuss, yeah, the cartographer instructions for installing. So let me just try to install these dependency, and then we can jump into the demo. I'm not sure which will, I mean, this fix will work or not, but if that is working we can save a lot of time. Like the build can take some time, so in the meantime we can discuss the G mapping. So let's see whether these fix work or not. If not, we can directly jump into the G mapping demo and how to save the map. I think last class somebody asked a question like how we can store the map. So SLAM is doing the mapping and localization, right? So how we can store the map, that I can show you. Okay, so let me check. Yeah, seems like it is building. Good. Okay, and let me check the system monitor, because if it is taking a lot of computation we can't able to run the other things. So in the system monitor, oh, it's using 100% CPU. Okay, yeah, okay, uh, yeah, that's what I think. It will take a lot of time to build. Okay, anyway, like we can jump into the G mapping again, and maybe we can cancel this operation for now, otherwise we can't able to run the G mapping. So one thing I have to talk about the G mapping package is that, just a second, yeah, SLAM G mapping tutorial, how to build the map. Yeah, so I think this tutorial is actually covering how to run the G mapping node and how to save the map. Okay, so basically we are going to see the turtlebot example and we are trying to save the map. Okay, in the last class I think we have talked about like how to start the G mapping node with the example. So let's see. Okay, let's see the turtlebot example, and from that we can start. So let me start the simulation of turtlebot using ROS launch gazebo, and we can use the turtlebot 3 world. Okay, and there is a package in turtlebot, that is turtlebot 3 slam. So we can simply start the turtlebot 3 slam package. There is a launch file, so inside that there is an option to select different slam algorithm. So if you just go to the launch folder, you can able to see the turtlebot 3 slam.launch, which is actually triggering each slam algorithm based on our choice. So for example, by default it is taking the G mapping as the default slam method, so it will be launching the corresponding launch file. So I can show you that. Just want to go to the Turtleboard workspace. So this is a workspace, and if you just go to the Turtleboard 3 package, can able to see the SLAM package, and inside that there are different launch file which is for launching different SLAM algorithm. Okay, so for the gmapping, we have seen we are basically running the gmapping node, and we are also setting some parameters. So gmapping node is actually having a ton of parameter. Like if you check the SLAM gmapping package, you can able to see a ton of parameters. So that is actually supplying from a YAML. So we have talked about it last class. So this is how we are running, right? So what I'm doing is I'm starting the mapping using the gmapping node. So ROS launch Turtleboard 3 SLAM Turtleboard 3 SLAM.launch. So we started the mapping, and the RVs will pop up. I'm just changing into orbit so we can move the map like this. Okay, and in order to move the robot, or in order to like manually control the robot, you can either use RQT. So using RQT, you can simply load the plugin called RQT steering. This is RQT steering, and you can provide the topic name of the command velocity, and then you can simply increase the command velocity. This is for the linear motion, this is for the angular motion. So you can see the robot is moving slowly and it is creating the map, right? Yeah. So yeah, so I'm just waiting for like completing the map. Yeah, maybe this will be enough. It's not complete, but yeah. So some of you have asked like how to save this map. So one of the main application of the SLAM algorithms are like mapping. Okay, so somehow we have to store this map. Okay, then only we can use this map for the next process, that is the localization. So the localization algorithm can help the robot to localize with respect to the map that is created. Okay, so in order to save this map, so we can simply go to the topic list. Okay, topic list, or maybe RQT will be fine. That can give you, I think, a good idea. So just go to the RQT node graph. Okay, computation graph. So if you take it, you can find how what are the different nodes currently working and what are the topic as well. So if you check, the ellipse is actually node, and the rectangle is the topic. So basically, what is the out, or what is the topic that is publishing by SLAM? It is the map topic, right? Map. And the SLAM gmapping is getting the TF, which is one of the input to the gmapping, and also it's getting the scan. So while configuring the SLAM algorithm or any nodes, you can simply take the node graph to make sure that these topics are, I mean, subscribing or it is publishing. Okay, so this computation graph is actually a good tool to debug. So sometime if you try to configure the SLAM for your robot, sometime it may not create the map. So you can simply take the node graph and check whether the scan topic is different. Sometimes the scan topic may be different, and also you can check the TF. So you can visualize the TF tree. So from that you will get an idea. It should be like this. Before running the gmapping, so the SLAM algorithm demands a TF structure. So for gmapping, it will be ODOM to base footprint. There will be a transformation, and base footprint to base link, and all the joints or all the frames in the robot. Okay, so if we have this kind of TF, then you can directly, I mean, run the SlamG mapping node, which will be subscribing to TF topic and getting the TF. Okay, so here what I'm trying to say is the publishing data is map, right? Publishing topic. So what we can do is we can use a ROS topic type slash map. So this will be showing the type of the ROS message type of the topic called map. Okay, and if you want to save this map, okay, so this map, this topic is actually visualized in RVs. So what you are seeing is actually coming from which topic? From map. So you can see here in RVs on the left side, if you just disable the map, it will go. Okay, so basically this map topic is subscribing inside the RVs and it's visualizing. So if you just echo it, ROS topic echo map, you will get this map data. Okay, it's zeros and ones basically. Okay, so this is the map that is creating by, or this is the output of the SLAM algorithm. So how to save it? That is again a question. So that's where this tool is coming. The tool is called map server. Okay, maps, there is a package called map server, and there is a tool called map saver, so which will be like subscribing to the map topic and writing into a file. Okay, .pgm file, it's a image file. Okay, so I'm just going to the desktop and running the map saver node, ROS run space map server space map saver, that is a node executable name, and I'm just giving like turtleboard 3. Okay, that is a file name. So if I do that, if I press enter, you can see here it is waiting for the map. Okay, and received a map with a dimension of 384 by 384, writing the map occupancy data to turtleboard 3 pgm and writing a map occupancy data to turtleboard 3.yaml. Okay, so this much process actually done by the map server, and let's see what's going on in the desktop. So in the desktop you can find turtleboard3.pgm, which is actually the map that we have created. Okay, it's an image file. You can simply open it by simply clicking it, and yeah, so this is the map that we have created. You can see some areas are not finished, right? So that is this, and there is a YAML file as well, which is having the information about the map file, its resolution. This is called the metadata. Okay, metadata means the parameters associated with the map file. So the resolution of the file, then origin, then some threshold values. So that information is available in the maps server package actually. So what I'm trying to explain is that this is how we are storing the map. So when to store the map? After completing the map. So like the map is not finished now, so what you can do is you can simply finish the map by manually moving the robot, or in the last class I mentioned the exploratory algorithms, right? So if you run the exploratory algorithm, the robot will be automatically going through these places and create the map. Okay, so the safest, not safest, yeah, exploratory algorithm will also work, but here we will get some control. It's a manual movement, right? Yeah, so simply move the robot. In a lot of application we are using exploratory algorithm. Even for one of my project actually we have used. It's very easy to use, but it depends on the environment, I will say. So in some situation, the robot need to be explored autonomously and need to create the map. So we need to put some nodes like explore right. I think I have shown you that last class, explore right algorithm, which is basically working using SLAM G mapping. So what it does is that, I think I have shown you the video, right? Okay, so I can come back to that. So we have completed the map. Okay, these are the obstacle. Inside the obstacle, I mean, we can't really map. So after completing it, you can run the command again, and the new file you can see is the map which is having all the data. Okay, so this map is using for the localization. Okay, yes. So I'm simply closing the G mapping and showing that exploratory. If you are not I mean, if you didn't attend the last class, maybe I can show you this is how the exploratory algorithm works. It's very simple to configure. Just run a node which can able to give random post goal to the navigation stack, and with the help of SLAM G mapping, it can able to create a map automatically, I will say. Okay, this is the Turtlebot 2, and yeah, so no one is controlling, the robot itself moving and it's finding the empty area and it's creating the map. Okay, yes. So now I think we can jump into the next topic, which is the cartographer. So I mentioned that there are different algorithms that is available, SLAM algorithm. So we are mainly first focusing on the 2D SLAM, and then we can also see some 3D SLAM techniques. I don't know I can able to run it, but we can discuss that, mainly the RTAP and then the HDL graph SLAM. Okay, so so now we are going to discuss the cartographer. The cartographer is not available in the Synaptic Package Manager or the apt package manager. We can easily install SLAM G mapping, like using sudo apt get install. You can simply install like Noitic SLAM G mapping. So using this command, we can simply install it. Yeah, I need to update it. So actually, the SLAM G mapping is a meta package, so we don't need to install. Sorry, we don't need to install. We only need to install the G mapping package. Maybe I can show you that. But what I'm trying to say is that these kind of packages are already available as binary. Okay, so we don't need to compile it from the source code. But cartographer, currently it's only available in ROS 2. I didn't see it in the ROS 1 repo. I'm not sure what happened. But I think their focus is currently into the ROS 2. Okay, ROS 2 development. So yeah, we can see cartographer while discussing ROS 2 as well. So now I'm just planning to like update and then try to install the G mapping. So so you may be thinking like, we already work with G mapping, so what is this package? So this package basically the meta package of G mapping. So once we install this meta package, all the G mapping related package will be installed. But for the test, I think we only install the specific G mapping package. So anyway, like I just want to show you this this command, like some algorithms can be installed like this, some are not. So we are jumping into the cartographer setup instruction. I think I have shared this link in the Discord. So it's actually straightforward. They mentioned that like for ROS Noitic, we need to just copy paste this command in terminal, and for older version we have to use this. And then the instructions are like, we need to like create a workspace, a Catkin workspace, And then there is a tool called WS tool. I think you remember, I'm not sure I have discussed that. So WS tool is actually helping us to download a set of repository. For example, you created a package. Okay, you created a package, and that package actually having some dependencies. Okay, some dependencies may be binary dependency, like we have installed the slam gmapping, right? So this is, we can call it as a binary binary dependency, in the sense we can install it from the binary. But some dependency you can't able to install from the binary. We may need to download it from the GitHub. Okay, so in that case, what we can do is we can use a tool called WS tool, okay, which is in ROS, which actually help us to automatically download all the repository. Okay, like here what happening is that it is downloading the cartographer git repository, and also the cartographer ROS repository. Okay, cartographer is an independent C++ library, and cartographer ROS is a wrapper around this library. So this WS tool will be fetching the packages from this .ros install file. Okay, and it will be like updating it, and also using the ROS dep command, which is actually very popular tool in ROS 1, which is mainly for installing the dependencies automatically. So you may be thinking like you have created a repository, or you have created a package, okay, and that package is having some dependencies, okay, some binary dependency, or some source code based dependency. So the source code based dependency can be downloaded using WS tool, and binary based dependency you can simply mention that in the package.xml. Okay, if you mention that in the package.xml, these binary will be automatically installed. So for example, I can specifically show you, like if you take the cartographer, let me just go to, not cartographer, the ROS dep is ROS specific. So let me check some package.xml, and you can see here, right, in the package.xml you can simply mention like depend lib gflags -dev. Okay, this is the package name actually. Okay, so if you do the ROS dep command, okay, this command, this command, okay, what happening is that it will be going through the package.xml, and it will check these dependencies are installed. So this is a very useful tool to make sure all your dependencies got installed. So the instructions are simple only, like just go to the workspace, the Carto workspace. I have created a workspace called Carto for this. So sudo ROS dep init, and you can do the ROS dep update, and this thing. So this has to be executed from the workspace folder, not from the src. Okay, yeah, so it will take some time, and if you execute this command, which is basically doing is that it will search for the src folder, and it will check, I mean, it will only focusing on the ROS distro. Current distro is Noitic, and it will be installed. This -y will be like install automatically, okay, without any question. It will be automatically installed. So there is a package called libapps-dev, which is actually not available for this version, and they also mention some script to install the same. Okay, so you can simply copy paste this, and after everything, like we can build this repository using this command. So you may be seeing a difference, like uh, commonly like we are using catkin make for building the packages, right? But here you can see they are using catkin make isolated. Isolated is actually like building each packages with, I mean, independently, I think. uh, Currently we are not using much, but there is some other things here like use ninja something, right? So ninja is again a build tool. Okay, build tool like cmake. Ninja is actually a build tool. So what we are doing is in the first command you can see we are installing the ninja build tool. It's a very lightweight build tool. So the cartographer can be built using ninja. So that's what they are saying. So if you execute this command, it will take some time to build. So in the meantime we can discuss about cartographer, and then let's see how it goes. Okay, so let me see if there is any progress. Just a second. Okay, as of now it is good. So we can jump into the cartographer website. So I'm not planning to discuss all the aspect, but we can see what is happening in the cartographer. Okay, so I'm just sending the tutorial page of cartographer, and where should I start? Okay, this is one thing to start, but this is not what I am looking for. The algorithm walkthrough. Okay, that maybe require. Yeah, I think this will help. And what are the other things to check? Let me check. ROS API. Yeah, this one. So I'm just giving the links that I'm referring. This one and the algorithm overview. I'm not very expert in the algorithm, in the sense like deep understanding is not there. But I have an understanding, like an engineer understand the things. We are mainly like focusing on the application side or how to implement things. So maybe I can explain the algorithm based on my understanding. Okay, so here this is actually the block diagram of cartographer. So very easy to understand, like some part, like on the left side you can find the list of inputs that we are going to give to the algorithm. So the common input that we are using for SLAM is laser scan, then the point cloud obviously, then the odometry, then the IMU, and the TF, fixed frame pose, basically TF. So for this SLAM algorithm also we are using these set of sensors. Okay, we can able to make use of these sensors. And if you can check, like there are there is a new thing coming on cartographer, which is actually sub maps. Okay, like it is creating I mean, it's not directly creating a single map, but instead of that it is creating sub map and merging it. So that's what I understood. Like so here if you check the input, like that is a laser scan, it's going through a voxel filter, like for the point cloud also, and for the laser scan also. The voxel filter is actually downsampling the data. Okay, so like we are for creating the map, we may not use the complete data from the sensor. We are using a downsampled version of the data, and we can actually adjust this filter coefficients or filter parameters, and then for every SLAM algorithm, the main thing is the scan matching. Not only in SLAM, but also in AMCL, Monte Carlo localization, there is a scan matching techniques. Scan matching, like comparing the different scans that is coming. For example, if the robot is moving, the scan will be also changing, right? So we can understand the changes by comparing the previous and current scan. Okay, so from that scan matching we can create the pose. I mean, we can even create odometry. So there are packages available to create laser scan based odometry. So like if you just check laser scan odo, there is a package called RF2O laser odometry, so which is basically creating the odometry from the laser scan. Maybe I can play this video for better understanding. So if you just check, yeah, so this is an illustration. So here the black is the ground truth, green is the RF2O, then PLICP is another algorithm. So they are comparing different algorithms. So green is the laser based I mean odometry. So when the robot moves, you can see the PSM is not working good, but the PLICP is again yeah, it's again a scan feature based thing, but you can see here how well is the RF2O works. Okay, it's not bad. Okay, it's not bad when compared with the ICP and PSM. It's worked good. So the similar strategy is actually using inside the cartographer. A similar strategy in the sense scan matching. Okay, from that we can identify the pose. So here you can find we are getting the odometry from the wheel encoders, and we are also getting the odometry from the pose observation, that is from the scan matching, and also we are getting some pose estimation from the IMU. Okay, so these pose estimate is going I mean that actually helps to understand the pose of the robot better. Okay, I think these three things are happening inside this. Okay, and based on this pose they are creating sub maps. That is what I I felt different from the G mapping. Sub maps is like it's not a complete map, but it's a section of the map. Okay, and then after creating this submap they are actually inserting it or merging it. So that is here they're saying the global SLAM. Okay, so that's what I actually understood, like there is a local SLAM and global SLAM. A local SLAM is creating sections of the map, and global SLAM is actually like stitching it. Okay, so this is what my understanding of the SLAM. And if you switch to the node side, like this is the implementation, like how cartographer works. For example, you can see here, right, the cartographer node. Okay, the elliptical shape is the node, and you can see the input and also the output. So what are the inputs? You can check. TF is one input, IMU is one input, then laser scan is one input, and what are the output in the sense what are the things it's publishing. It is publishing submap. Okay, then scat match, point, trajectory, landmark poses, and also I mean from the submap list it is going to the cartograph occupancy grid. So seems like this node is publishing the submap, and then this node, no, the cartograph occupancy grid node may be merging all the submap. That is what I understood. So like creating submap, stitching it. So here we can see the input, each input details like scan. Then we can even insert multi scans or multi echo laser scan. For example, you can see here vertical and horizontal laser scan. Scan ROS. Let me check. There is an option to put I mean vertical laser scan continuously rotating. I think it's in the example of cartograph. I will show you that. So it's a combination of two laser scan or multiple laser scan. We can actually give multiple laser scan as the input to cartographer, not only single. Then we can input the point cloud, so that can be used for 3D mapping, and we have additional data like IMU and ODOM. Yeah, so I'm just checking the build, guys. Seems like it is progressing, no errors so far. And we can also see like the published topics, like what we are interested is the submap. Then there are scan match points, and there are some service also it is providing. And here it is it is actually demanding this TF basically, not the map is actually publishing by the cartographer, and even ODOM to baselink can be also published by cartographer, but basically we should have a TF structure like baselink, then the laser scan, IMU, and the ODOM should be there. Even one application of cartographer is we can create the odometry with only using LiDAR or only using laser scan. So imagine if you don't have access to the wheel encoders, we can use the cartographer itself to create the odometry. So that is also an application. So these are the node input and output, and so from this I mean computation graph, you can see the submap list. The submap list, just a second. Yeah, the submap list topic is actually going to another node. It's called occupancy grid node. So that is actually subscribe to submap list and then publishing the map. Okay, so that is what the final output of the cartographer, which is basically the map topic, and using the map server we can able to save it. Okay, yeah, I think the cartographer is successfully built. So what we can do is we can just put the workspace, just a second. So we are simply taking the sourcing command into our bash RC. So it will be sourcing always, and okay, and we can also check with ROS CD whether it is detecting. Yeah, so seems like it is detecting the package. Okay, it is installed. So now what we can do is we can start the simulation of Turtleboard 3, and inside that we have the cartographer testing launch file. Okay, so we can do that. Just a second, just okay, Turtleboard 3. Okay, going to the package, that is SLAM, and then checking the launch file, and in the SLAM maybe you don't need to change here, you can give it in the command line itself. Just take the SLAM methods, which is actually an argument to this launch file. Okay, so if you just give SLAM methods to cartographer, then it will be loading the cartographer launch file. Okay, so what I'm doing is I'm just starting the launch file and then cartographer. Okay, I am expecting that it will be launching, but before that I'm planning to source that package, then only it will be detecting. No, not cartographer ROS, cart workspace, then devel isolated setup.bash, and now slam method cartographer. Okay, so let's see if there is anything happen. I'm not sure because I didn't tried it yet, but seems like there is some issues. Check failed sensor tracking. Yeah, I think there are some issues. Seems like it is failing. So seems like because the Turtleboard 3 guys, maybe they have tested with that version. I mean at that time, but there are some changes happened, and seems like it is crashing as well. The launch file is crashing. So I'm not sure whether we can fix it, but seems like it will take some time. So add a trajectory ID, check failed sensor tracking. Okay, maybe we can disable the IMU as well. Let me just go to the cartographer launch file. Yeah, so this is the launch file, and the cartographer actually require some parameters. So this is how we are starting the cartographer node. There are two nodes actually. One is the cartographer ROS node, which is publishing the submap, and this is the occupancy grid node, okay, which is actually subscribing the submap and publishing the map. Okay, and this is the configuration file which is having the different parameters of cartographer. So I'm not sure you heard about the language called Lua. Okay, there is a a language called Lua, like Python. So that is what they are using as the parameter. It's not like YAML file, it's actually Lua. So it seems like there is two files. One is the 2D Lua and one is the gazebo. Seems like this file is what we require for working with the simulation, and this is for the hardware. So what I'm trying to do is, as a fix, I'm just going to the launch file, and in the cartographer file, what I'm doing is I'm just changing this file to gazebo. Okay, so I'm not sure this will work or not, but let's have a try. Okay, so let me start it again. We change the Lua file, which is having some configuration that we will see. So I'm starting it, and I think it's the same issue that no, just a second. Okay, even if we change the file, it is actually taking the same file. Okay, so that I think it's not. Okay, so this is the cartographer file, but it is still taking. Okay, got it. So I'm just going back to SLAM and okay. So here this is a slam.launch, right? So here also we have to change. So what happening is that this configuration file is going to this configuration will override the settings inside this launch file. Okay, so that's what happened. So we have to change from the main launch file. So if you run it now, let me see what happened. Yeah, so now it is working. Okay, that's great. So you can find it's working. Just a second. Yes. So this is how the cartographer works. Yeah, it's working perfectly. And now we can start the RQT, and we can try to move the robot. Let's see how the mapping will be. I can see some wobbling, like you can also see, right, like some kind of vibration. uh, and there is an option to visualize the submap, and also, yeah, okay. So you can see the map is getting created. um, okay, local map, global map. I think it's lost some posts, right? Yeah, it's actually crashed. There are some issues is happen, I think. Yeah, but still I think it can able to build. Actually, you can see the robot actually reach here. But the I have actually enabled and disabled some parameter here, so I mean some, so it's actually crashed, but seems like it is building. Okay, maybe we can just start it again, and then we can switch to the next one. Let me do that again. Okay, the launch file, then gazebo. Okay, I'm starting. Okay, we started the simulation. Now starting cartographer. Yes, now I'm starting the RQT to drive the robot. So now we are not enabling or disabling, simply we are moving the robot in front. So just keep on working. So we can have a look on to the terminal, the second terminal, if there is any error. And in the background you can see the map is getting created. But still there is a vibration, I think. I'm not sure. Yeah. I'm just checking the. Okay. Okay, I think they have. Okay, I got it. I think if my assumption is correct, let me stop this. Oh, it's actually hit. Okay, okay. Yeah, so what happened, guys? I think when you start the cartographer launch file, they are running both actually, the navigation stack and also the cartographer. Okay, so if you give a goal position, it's basically using the map from the cartographer and also the localization. Yeah, so this is actually interesting. Maybe I can run it one more time, so you can actually have a look onto it. So yeah, so that's actually interesting. So here what we are doing is, in this launch file we are starting not only the cartographer, but also I think we are starting the move base. Okay, move base is basically the navigation stack. Okay, so the I mentioned, right, for the exploratory algorithm, we can use the G mapping and the move base, and also the exploratory algorithm for automatically map the environment, right? Similar to that, these guys actually included the navigation stack along with the cartographer. So what happening is that cartographer can do the localization and mapping. So if you do the 2D navigation goal here, it will be like moving uh, in the map. Even the map is not created, but it's actually trying to create. Okay, it's trying to create and it's creating. Okay, but you can find some issues for sure. There will be issues, but it will work. Okay, if you fine tune the parameters, we can do the navigation and the mapping using the cartographer. Okay, there is a wobbling, there is a vibration, but still it actually good. So it's creating the map. Yeah. Okay. Yeah, seems like it's created the map. Mostly it's completed the map. So maybe we can have a look on to the RQT, the node graph. So how is it communicating? Let me take the introspection node graph. You can see here we have the navigation stack running, then the cartographer node. The cartographer node is publishing the submap list, and that is publishing by the occupancy grid, and we have the map here, map topic. Okay, so we got the map. So how to save it? The same command that we have used. You can use the ROS run map server, which is a package, and the map saver is the node name, and carto map. Let me see how it goes. Yes, so seems like it is written as a file, and you can see carto ROS. Let me see whether it's created. It's actually given the message, but I'm not able to see the file. Where is it? Oh, it's in the home folder. Yes. So this is a map that we have created, guys. Okay. So yeah. Okay. So anyway, these all are some default parameters, but we need to fine tune it. Then only we can create the better maps. But it's still working. It's still working with the Noitic. That's a good thing. Yeah. So in order to test the cartographer on your computer, I will suggest you to set up the cartographer first. Okay, as per the instruction. It's not a difficult stuff for you, because the instructions are it's already there. Okay, it's already there, and in order to have a test, okay, you can do two things. One is like you can test it using gazebo, okay, and one is using the back file. Okay, by the way, I didn't mention the parameters of the cartographer. I actually forgot that. So if you go to the turtlebot 3 slam package config, you can see two files. This is what we have used. This is how the Lua files looks like. So you can see it's similar to the YAML, but you can find like the map frame, then tracking frame, the published ODOM frame, then provided ODOM frame. I mean, if we have an ODOM already, you can say you have provided use odometry. So if you want to use the wheel odometry, we can make it true. Then number of laser scanners, then multi echo. So all these things we can mention, and these parameters, no, these parameters actually it's in the tuning methodology, I think. Let me check where is this parameter. I think it's in the, I have seen that actually. Yeah, I think this, no, not this. So it's already, I mean, all these parameters are there, so we have to configure it. That is actually the tough thing, I will say. So either we can take some existing configuration, like Turtleboard, and then we can like do some trial and error. Otherwise, you can go through the parameters that they have mentioned here. Just a second. Yeah, I think they have mentioned some parameters here. Global SLAM, tuning methodology, ROS API documentation. Yeah, so this is one thing we can check. These are some back file that we can test it with the cartographer, so that is also interesting. So there are back file from MIR robot, PR2 robot, so all these things we can simply download and test it. That's actually good. So regarding the parameters, I need to check. I think this is the configuration. Yes. So I'm just sharing it. So this is the reference, Lua configuration reference documentation. So you can find all these parameters and these definitions. So simply go through it and then configure this Lua file. So you can compare with the gmapping. In gmapping, we have written the configuration in a YAML file, and this is a YAML file. And in the ROS wiki, you can able to see all the parameters. And for the cartographer, it's the Lua file. So we can fine tune the options of the node inside this option. Okay, this tag. I think all these things are for the nodes, but these things, no, these things are for the the local SLAM and global SLAM thing. There are a lot of parameters that we can tune. So yeah, so this is what the cartographer, which is actually started by Google, I think. Cartographer started by Google, and it will work in most of the system. It will not take much CPU. Okay, it will work the system where the gmapping works. Okay, we can use it. Only disadvantage that I have seen is that like we need to do the compilation, source code compilation. Yeah, but for ROS 2 we can install directly from the binaries. Okay, so just go through the documentation and try these examples. Using back files, you can simply able to create the maps. Okay, yes, so then you will get an idea. Okay, so I think last class I have shown this video, right? It's embedded. This is actually the cartographer which is running with exploratory algorithm. Okay, so the robot can automatically explore and map using cartographer. Okay, yes, so maybe if we have time, maybe we can go with one more algorithm. I'm not sure. I didn't expect it will take this much time, but maybe tomorrow we can complete these Hector and Carto. I think because cartographer obviously took some time, but Hector and Carto SLAM, it's very similar to the gmapping. Okay, so I'm also sharing the cartographer ROS package. Yeah, so maybe we can directly jump into questions, guys. So today we have started with the gmapping, saving of map, and we have discussed about the cartographer. So let me know if you have any question, guys. So maybe we can jump into questions. Yeah, Urvashi, I think you have some questions to ask. Let me know. Yeah, tell me.
With cartographer use stream extension for the map.
I think your voice is breaking sometime. I'm not able to understand this correctly.
Yeah, now can you hear
Yes,
me
now, yeah,
properly?
now it's fine.
Yeah. Okay, great. So for with cartographer, shall we have to like use PB stream extension, or we can use YML extension too?
Yeah, so for working with the cartographer, for example, if you want to use the cartographer on your project, okay, on simulation or something, only thing is that writing a launch file and putting the configuration. It's .lua. Lua is actually, yeah,
Yeah,
yeah.
uh, I'm trying to save the map using PB stream extension, but like I don't know whether I can use PB stream or YML file extension.
Actually, I have shown you this, right? We can, using the map saver, we can store using PGM, and we will get two files actually. This YAML, no,
Yes.
this is actually the meta file. If you just open it, it is having the metadata. Like for an image, you can, right, there will be some meta information. So for example, if you just maybe I can take a screenshot, and in the screenshot, if you check the properties, there will be some meta information like these things.
Yes.
So like that, for the map as well, there will be some meta information like resolution, all the scale and all. So we are storing the image, we are storing the map in .pgm file, but in the YAML file we are storing the meta data of the file. That's how it is working.
So we don't have to use like we don't have to use store map as PB stream. We can use a YAML file too.
Yeah, actually, YAML file is having the details of this map, like what is the map file. Okay, so what is a map file? So if you use the YAML file, we will get the map file name. So after getting the map file, we can open that file. So basically, map is the PGM file, but the data information is in the YAML file. So if we are using, for example, um, if we want to use the localization, um, MCL ROS, just a second. Yeah, so let me just go to the navigation of Turtleboard, then you will get an idea. Yeah, so you can see here the map file they are pointing is the YAML file. So why is that? Because the YAML file is having the information about the map file, I mean the image file and the information. Okay, so this map file is actually going to where? To the map server. Okay, so this is the launch file for the navigation. Okay, I think you may have seen this before, like for starting the navigation, autonomous navigation, we need to publish the map using the map server. Okay, we need to start the AMCL, which is actually the localization. We need to start the navigation stack, which is the move base, and we need to start the RVs. Okay, so these you may be confused with the YAML and the PGM file. Basically, we have to pass the YAML file to the map server, so the map server can read the map location, and it can publish that map. So that's how it is working. So instead of the Kato PGM, we can also mention the path like robot, this kind of thing. So it will be loading the corresponding map. So that is the importance of IAML file. Urvashi.
Yes,
Okay.
sir. Sir, is it possible I'm having perfect automat I'm getting perfect
Okay.
autometry for you're using this cartographer's lab cartographer,
Okay.
and still my localization of the robot is not perfect. So I'm also using AMCL node, but still it is not perfect. Like the map is the scan is rotating respect to map. So is it only because of this localization issue?
No, actually, the map is rotating. That is a different thing. Yeah. So these are some common issues that we can see. So one is that like if we can fix the fit an IMU, that can fix the issue, because if you what that I need to check that, because if you fit the IMU, then it will give you the orientation value. So basically the map is rotating during the navigation, right? During the navigation is what the map is rotating, or in the mapping itself. I think it's the
No,
navigation, right?
not only
Navigation,
navigation,
yeah.
yes.
So one thing can be like you mentioned that you are running the AMCL and cartographer in parallel. I think you may be using cartographer for getting the ODOM. Is that correct? O-
Yes,
Okay,
I'm doing whole navigation with
cartographer. Cartographer.
photographer. Yes.
Okay. So if you are using the cartographer, I think you don't need to use the AMCL, because cartographer
Okay.
is doing the same thing as AMCL does. AMCL only do the localization, but cartographer can do the localization and mapping. So I think, and it can also give you the pose. So I think this rotation can be of many things. Like if you have a good IMU, I think we can solve this issue. IMU is one thing. Otherwise, maybe what you can do is you can simply record the video and share it in Discord, so we will get a clear understanding. Mostly it will be because of the IMU. In order to solve that, there are some methods. So I need to check that, like what is the specific issue.
Yes.
Yeah, yeah. I have seen your message, but like I mean, from Monday to Friday, I am like fully occupied with some project. Like the latest project that I am doing is taking a lot of bandwidth from me. So yeah, so that is what the current situation. Anyway, like
Some
yeah,
uh someone has mentioned my maybe I'm having TF issue.
yeah,
Is it due to
yeah,
TF
yeah.
issue?
I mean, that's what there are multiple causes for that. Multiple causes. Like, for example, if just a second. Yeah. So the problem is that in order to work with the navigation, we should have ODOM to base footprint TF, and also base footprint to the base link. That is actually these all are belongs to the robot URDF file. I mean the robot description. But this thing, no, the ODOM to base footprint. So this thing is actually publishing by the driver. The the driver is actually the basically it's reading from the wheel encoders, and it's computing the ODOM and it's publishing the TF. So if you are having any issues with the ODOM to base footprint TF, then also this can happen. So you have to make sure you are getting this TF frame first, and after that you can check if there is any issue with the ODOM to base footprint thing, because that should be also correct. So and also you can compare with some I mean how other robots publish this ODOM to base footprint. Yeah, so because if the ODOM to base footprint orientation is not correct, then the robot will rotate. So that's what, there are many chances. So I need to check which will be exactly the problem that you are facing.
share it in
Okay.
the
Okay.
Discord.
Okay. Let me check. I can. Yeah. Yeah. So I think we are good to go, right? So maybe tomorrow or day after tomorrow, I can update when can I do the session. So tomorrow we will be continuing with the 2D slam and 3D slam, and then we will be jumping into the next chapter. Okay, guys. I think thanks for attending the session, and let me know if you have any questions. So I will be uploading two notes. One is the Slam 2 and Slam 3 session. Yeah. Okay. Okay then. See you tomorrow. Okay then, guys. Bye. Bye, everyone.